Hello everyone, it's Milasoft. Welcome to my channel. In today's video, we're going to take a look at removing the protection from Pool of Radiance. In the middle 1980s, disk copiers were becoming a little bit more advanced. You could copy up to track 40, and a lot of copiers were including the ability to copy disk errors. So publishers had to come up with new methods to try and keep people from duplicating disks. With the game Pool of Radiance, what they did was they introduced a code wheel, which was a physical wheel you would turn and line up to get the icon that they were asking for. And then there'd be a word. So you had to have the wheel if you wanted to be able to play the game. Copying it wasn't the issue, copying the disk wasn't the issue, but getting the wheel was a different story. So without further ado, let's dive into this one. We have a boot file, and I haven't learned to type since the last video. Oh, it's a basic loader, okay. Disables run, stop, restore, linker, library. Okay, well, let's give it a run here. Disable fast loader. No. And I'm using CC64 emulator on a laptop. You can also use Vice emulator on a laptop or a desktop as you see fit. If you have a real 64, you can also get a snapshot or an action replay cartridge, plug it in to the cartridge port, and follow along with these lessons. So we're on the title page of Pool of Radiance. We're going to press a key, and we have the credits. Play game or demo. We're going to play the game. I think I have my joystick disabled. I use the cursor keys for the joystick, and then I disable it so I can type on the screen using the cursor keys. Alright, use the translation wheel to decipher the code word. Match the Asprur rune outer ring with the Dethic rune inner ring and read the code word under the path. So let's freeze it, pressing F12. If you were using Vice, you would go up to State and save a frozen state. That just allows us to get back to where we were, instead of reloading the game if it crashes. So we get one try, wrong. We get 2 tries. That's not a very forgiving game. It gives you 2 tries and that's it. And you can see it's in an infinite loop. And we find that by typing Alt-M for the machine language monitor and looking at PC that tells us what instruction is currently being executed. Whatever's at address 12F4. So we disassemble 12F4 and it's jump 12F4. So it is jumping back in an endless loop. Now that we have created a snapshot, let's load it. And if you've watched my videos before, I have a technique. It's a technique that works quite a bit of the time, and that is to enter a series of, let's say, numbers in this case. Let's use 2112 as in the Rush album, and then we're going to press return. We'll go Alt-M to get into the emulator. And now that we've entered 2112 as a password, let's see if we can find it in the memory. Now, someone asked me if you had to bank out the ROM. Banking out the ROM means that you type in bank 0, and it gives you from A1000 all the way up to F1000 as RAM. In this particular case, I'm just kind of relying on my experience to trust that the code is going to be in the normal locations. Now, it didn't find anything, so let's hunt for 32, 31, 31, 32. Okay, let's try that again. 2112, enter. Hunt for 32, 31, 31, 32. And we have 2 results. Now, you might be asking, why is it 32, 31, 31, 32 instead of just 2112? The difference is 2112 are just, we'll call it decimal values, like the literal number 2, and then a 1 and a 1, whereas 32, that is what we call PETSCII. So that is, if you do a search on the internet for Commodore PETSCII table, you'll find that the number 1 is actually 31. So you really just add a $30. All right. And we found it at 9700. So if we look at 9700, now let me just put a 2112 here, and you can see the difference. Here's a literal 2, a 1, and a 2, and the result is BAAB because it's put a 2 in memory, a 1, and a 2, whereas the PETSCII, the actual numbers, 2112. With having said that, we are now going to use the H command to hunt from 0000 to A1000. It doesn't have to be A1000, but A1000 is usually where most code stops. We can go further, but for this example, we'll use A1000. And we're going to hunt for 0097, because when we write out a 16-bit address like this, we do it backwards with the low byte first and the high byte second. And you can see that we have 4 results. So we're going to disassemble the first one. And what it's doing is it's loading Y with 6. It's loading what's in 4C, comma Y, comparing it to 97, comma Y. If you watched my last video, I told you that when you see a number in brackets, because there are 2 brackets, just think of it as you're looking up 2 values. It's what we call indirect addressing, which means you're indirectly accessing memory. We put a byte in 4C, and we put one in 4D, and then when we call it in brackets, it's just another way of saying load CF20. I think they were just trying to be a little bit secretive. So 4C is CF20 and Y is 6. So 0, 1, 2, 3, 4, 5, 6. Space, exclamation, exclamation, that doesn't look right. That doesn't look like, that's what it's like, a password. But we do know that there are passwords at 9700. So I'm almost certain that this is the routine we're looking for. Let's just go 12D9, jump 12D9. Oh, that's it. We only got 1 try. And now we're going to type Aussie. And we'll go back to the routine. 4C is set to 1063. Oh, look at that. Night. So let me see here. Y is 6, and you're loading 1063, 6. So 0, 1, 2, 3, 4, 5, 6. It's a 0. And you're comparing it to your password, which is at 9700. So 0, 1, 2, 3, 4, 5, 6. If you had typed in night, it would be right here. And when it does the compare, it would be equal. Let's just restore our freeze. So this would be night, and this is Aussie. Not equal. We don't have the code book. We have a, we're copying it. We made an illegal copy, so it's branch not equal because they don't match. And if it's not equal, it goes down here. If it does match, let's say I typed in night. So that's a match. Decrement y. Y becomes 5. So 0, 1, 2, 3, 4, 5. We'll say it started here. And then it's a match, so it decrements to 4, 3, 2, 1 until y hits 0. And it just does an RTS. So this is if you get it wrong. And then somewhere in here, there's probably going to be a counter that gives you 2 tries. It looks like it would be here. Load 13.7a. Not equal, go here. So let's say 13.7a is a 0 when you load the game. You get the password wrong. It branches down here to 12. DF. Increments 13.7a to 1. And then the next time you run it, yeah, right here. Here's your infinite loop. So how do we crack it? Well, this one's a little bit easier. This is probably one of the easiest ones I've seen, actually. To do this, we're going to take a look at the bytes right here. We call these opcodes, O-P-C-O-D-E, when you spell it correctly. And an opcode is just a 2-digit representation of what the actual machine code is. So when you look at memory, like the actual memory of the computer, this is all that's in there. This is just these bytes. And the 6502 processor in the Commodore understands what these bytes do. It knows that this is for load, and then this is the address. This is just basically for us humans, an English representation. So we want to look for these 3 opcodes in this order: D90097, because we're fairly confident that, well, let's just see if they exist anywhere else in the game. D90097. Just there. See, if we did a search for something like just D9, here's what would happen. You'd have a shit ton of results. So we need to make sure that we have the exact set of bytes. So now that we know what bytes we're looking for, D90097, which translates to compare 97, y. We're going to go to my favorite program, and I use that a little bit sarcastically because it's sometimes it works, sometimes it doesn't work. When it works, it usually works great. Discan. You can find it on CSDB. I will leave a link in the description. And it basically just lets you hunt on a disk for bytes, because you can't. Searching memory is easy, but searching on a disk, you'd have to go through every track and sector or every file. So we press E to enter in the bytes in the order that we want to search for them. D90097. Press return. Press F to find bytes. Start on track 1, sector 0. Make sure that we have the right disk in the drive. Enter. I'm going to, it's already in fast mode, so it's okay. And we're just going to wait and see what happens. We didn't have a lot of these tools back in the early days of cracking. I'm not sure how people were able to do it. I know that for some of the early games, like the Epix games, like Summer Games, etc., when they were cracked, when you had the original, it was just, a loader file. That was it. And then some of the cracks, you actually had files on the disk, and they were called, like, for example, T3S2, which meant track 3, sector 2. People were able to rip the tracks and put them into files. So we found the 3 bytes. We're going to put yes for modify. And in this case, we have 2 options. We can modify 680 directly on the screen, or input the bytes manually by pressing I. So I'm going to go into the monitor and just modify them on the screen. And the bytes that we are looking for are here. And this is another one of those games where a single byte, one single byte, is all that's needed to break the protection. So if this is comparing the right password with what we put in, and it's not equal, we can take this out. We can put an RTS right here. We just have to cancel out this whole thing. So let's take the path of least resistance. Let's just, right here at the very top where we load Y with 6, put a 60, which means RTS, return. It just exits the routine. An RTS is the equivalent of a return, as a JSR is to go sub. So when this routine's called by a JSR, when it finds RTS, it exits and quits. So exit, press S to save these changes, yeah. And we are going to give it a go, see if we work. Disabled fast loader, no. Insert disk 1, okay. Press a key. Play game. Input the code word. Insert disk side 3. We have successfully cracked it. And it took us all of about 10 minutes. And we saved it to disk, and now you can pass it out to your friends. You could slap an intro on it. You can say that you're a super elite cracker. And I thank you for watching this video. This is Milosoft saying, have a good night.